Good afternoon to all of you. Myself, Professor EMI Power from SNT College of Engineering and Research Center, Development. In a previous video, we have already started the new topic of the course, that is electrical measurement and instrumentation, measurement of power in a three-phase system. In that, we have already studied that the construction working principle of the dynamometer type wattmeter and LPF type wattmeter, and two measurement of power, three-phase power by using two wattmeter method. Now in today's lecture we have discussed about the measurement of three-phase power by using three wattmeter method and one wattmeter method. Now first topic is measurement of three-phase power by using three wattmeter method. The in three phase power measurement by using three-phase wattmeter, there are three separate wattmeters are used for the measurement of the power of separate of each phase. Means the wattmeter which is connected across the each phase of the winding, each phase of the load, each phase of the load. Means the current coil of both the wattmeters W1, W2, and W3 are connected in series with the phase, and the pressure coil of the both the all the wattmeters are connected across the phase line and neutral. Then means suppose W1, the current coil of W1 are connected in phase R. Then the pressure coil of W1 are connected in between phase R and neutral. Uh, like this, similarly for W1 and W2, the current coil of W1 and W2 are connected in series with phase Y and B, and the pressure coil of both the wattmeter W and W2 are connected between phase Y and phase B and neutral. Then means all the pressure coils of the wattmeter W1, W2, and W3 are connected to the neutral coil. For measurement of power, how much wattmeters are required? This will be find out by using Blondel's theorem. And the Blondel's theorem states that when power is supplied by the K wire AC system, then the number of wattmeters required to measure power is 1 less than the number of wires, that is K minus 1, regardless the load is unbalanced or balanced. Balanced or unbalanced. Three wattmeter method of three-phase power measurement. Three wattmeter method is employed to measure three-phase power in a three-phase four-wire system. However, this can be also employed for three-phase three-wire delta connected load. Then the power consumed by the three phases is the W1 plus W2 plus W3. Means the total power consumed by the three-phase load, that is total power is equal to W1 reading of W1 plus W2 plus W3. Means the total power which is the addition of all the wattmeters. Next method is measurement of reactive power in a three-phase balanced circuit by using single wattmeter method. In that system, the reactive power which can be measured by using single wattmeter. For the measurement of reactive power, we have taken the load, that is uh, inductive load or capacitive load, which have contains the reactive power. The connection of wattmeter, the current coil is connected in series with the phase one phase, and the pressure coil of the wattmeter is connected in between the remaining two lines. Suppose the current coil is connected in series with the line 2, then the pressure coil is connected between the line 1 and 3. Then the reading shown by the wattmeter, this is the reactive power consumed by the load. And how to calculate calculate this reactive power? This will be derived from this derivation. Let the current through the current coil is I2 and the voltage across the pressure coil is V13. Then the reading of the wattmeter is V13 into I2 into cos of 90 plus 5. This 90 plus 5 which will be taken from the phasor diagram. From the phasor diagram. Then root 3 VI cos 90 plus 5. 90 plus 5 means it is equal to root 3 VI sin 90. VI sin 90. This is the reading of wattmeter. Means this will be used to measure the reactive power, that is root 3 VI sin 5. VI sin 5. The reactive volt ampere of the circuit is Q is equal to 3 VI sin 5 is equal to minus root 3 into reading of the wattmeter. And the phase angle is tan inverse phi is equal to tan inverse Q upon P. Q is our reactive power upon active power. This is the phi. Phi is the phase angle. This is the power factor angle. Next, what are the different types of power? Active, reactive, and apparent power. The active power means the power which is consumed by the load is the consumed by actually consume the load or utilize the load, utilize the power. This is called as active power. And apparent power, this is the product of root mean square value of voltage and current, that is RMS value and RMS current. It is called as apparent power. And the power which will be flows back and forth, that means it moves in the opposite both the direction in the circuit or reacts upon itself. It is called as reactive power. And the unit of reactive power is VAR. This is our power triangle: active power, reactive power, and apparent power. This is the difference between active and reactive power. This is the definition. This is formula: P is equal to VI cos phi, Q is equal to VI sin phi. Unit is watt. VAR representation by P and Q. It produces heat in the heater and it measures the power factor of the circuit. And the measuring instrument is wattmeter and VAR meter. And this is the method which is used for the measurement. This table which will give the reading of the wattmeter as per the power factor angle. When the power factor is unity, then both the wattmeter shows the reading positive. If the power factor is in between 0.5 to 1, both the wattmeter shows the reading positive and W1 is greater than W2. If the power factor is 0.5, then the only one meter shows the reading and second meter shows the 0. If the power factor is less than 0.5, Then one meter reading shows the reading positive and another is negative. And if the power factor is 0, then the W1 shows reading positive and W2 is shows negative. And both the wattmeter shows the reading same reading and the total power is 0. This is your conditions of showing the readings of W1 and W2 as per the power factor of the circuit. Okay, thank you.